Welcome back. Today we're looking at finding the inverse of a function algebraically, and then we're going to graph them on our TIs to see how the original function looks compared to its inverse. So starting off, whenever you want to find the inverse of a function, the first thing we're going to do is replace f of x with y. We'll rewrite everything. Now we'll use the definition of what it means to be an inverse. What happens is we're looking at switching the x variable with the y variable. So we will do that. So y turns into x, and x turns into y. Now at this stage, we're going to solve for the new y. And I always say new because it's different than what we started with. So if you're going to solve this rational equation for y, first thing I would do, I would multiply both sides of the equation by the LCD. So I'm going to multiply both sides of the equation by y plus 5. So you'll see the left side of the equation, it's a binomial times a monomial. I'll distribute. So I should have xy plus 5x. Write that a little nicer. On the right side of the equation, the y plus 5's divide out, so we're left with a 1. Now reminding ourselves that we're still solving for y, I will move the 5x over by subtracting it from both sides. I still have xy equals 1 minus 5x. And then divide both sides by x so that we isolate the y. So I'll move over here just a little bit. I will have y equals 1 minus 5x over x. Now this is almost done. The last thing we need to do so we don't confuse our final function with our original function is rename the y as f inverse. So f inverse x equals 1 minus 5x over x. So now we have found the inverse. At this stage, what I'd like to do is graph the original function and the inverse on the same axis in DTI. So we'll move over to our TI. Looks like we have an old problem here, so let's clear out. Let me zoom to standard first. I'm feeling we're going to have a nice 10 by 10 window. We'll go clear out our function. And we're going to enter y1 as the original function. So I'm going to just take a look back without you guys seeing. I have 1 over x plus 5. So 1, and I'm going to enclose that denominator in parentheses. And my y2, at least my version of my y2, I should have 1 minus 5x over x. So that would enclose our numerator in parentheses, division sign, and just an x. Press enter, and let's graph them. So you'll see y1 gets graphed first, then y2 gets graphed second. Now let me copy this over. It looks like we have rational functions, and sometimes the TI doesn't get the whole picture. So I'll see if I can copy it over so we can analyze it. Switch over to our original work, and I'll copy it over to the side. If it will let me. There we go. Let me just widen this out a little bit. Okay, so just a reminder, in blue was our original function. So we had F, and in red we had F inverse. And it looks to me like we've got asymptotes going on, so you can kind of tell, by our studies from the previous chapter, we do have an asymptote at x equals -5 for the original function. So it doesn't hurt to draw it in just so that we can see. And then that means our blue function probably would, whoops, let me change that color again. We're going to hug that asymptote. That's usually how that works. So a little more accuracy going on. As well as the red, if you look at the red function, the inverse function, it appears that our vertical asymptote is at x equals 0. So it's the y-axis. And similarly, you can tell that your inverse is going to hug that vertical asymptote as well. So the reason why these problems like you to graph the function and its inverse on the same axes is because there's a very, very special relationship that you can see. Now you do a lot of these and you will notice that if you've found the correct inverse, the function and its inverse are symmetric along the line y equals x. And let me see if I can draw it with a steady hand. So y equals x kind of does this. Feel a little more confident there. There we go, got a little straight hand. And so this just means if you find one point on one side, and it's really hard to find an accurate point, but I'll try. You'll see on the other side, you have the same idea. So let's say this point was -4, about 1. We would have 1, -4. So it's probably not, but just in case, there is some nice accuracy going on here. So I'll allow you to explore that, but that's a great way to tell if you've actually found the correct inverse algebraically. If you can fold well, you can't really fold your calculator, but if you could fold along the line y equals x, then you could kind of have a better idea that like, oh, I'm on the right track. So I hope this helps. I'll see you for the next example.